What's going on, everybody? It's your boy Kilo Loco, and today I'm going to be showing all you iOS developers how to get started with Flutter development. That's right, you're finally going to learn some cross-platform, and you don't even have to write any JavaScript. It's gonna be amazing. So today I'm actually going to be showing you how to implement an app where it's going to be essentially a Urban Dictionary app. You're going to be able to enter in a term. You're going to search for that term against the Urban Dictionary API. You're going to pull up a list of results, and you're going to be able to click on the result to see what the definition is. You'll also be able to see things like the amount of likes and dislikes on that specific definition. So that's what we're going to be covering today. Now, like I said, this is a crash course for iOS developers. But if you're not an iOS developer, that's absolutely fine. I'm going to be going over everything step by step, but I will be referring to some iOS specific terminology, some from UIKit, some from also Swift UI, because Flutter is declarative UI and it's most like Swift UI than it is UIKit. So some of the terminology is going to be coming from Swift UI. So just keep that in mind. But let's jump right on in. And the very first thing that we're going to want to do is open up our editor, and we're going to go to flutter.dev, and it should come up to a page like this. You're going to go up to getting started, then you're going to hit Mac. I'm assuming you're on Mac as an iOS developer, and you're going to want to run through this whole entire getting started flow. Now, as you can see here, it's saying that you either need to download the Flutter SDK. I'm going to recommend that you actually clone it if you plan on using Flutter more in the future than just this single video. So I would recommend that you clone it so that you can always just pull the latest code, and it's a lot easier, but it is also a manual process. But either way, just get the Flutter SDK onto your machine. From there, you're going to run Flutter Doctor. Flutter Doctor is going to essentially assess your system, see if you have all the requirements for Flutter to run essentially seamlessly, and have like a very good experience. If you are missing things, which you definitely will be missing things at first, then it's going to recommend that you fix those things, and you could run Flutter Doctor, and it should give you a detailed description on how to fix those things. Scrolling down to the iOS setup, you should have all this stuff set up, but you do want to make sure you go through and still run these commands just to make sure that Flutter is set up properly on your machine. You should have the simulator already set up and things like that, and Xcode and all these other things should be fine. Now, Android Studio you may not have set up on your computer, and I do recommend that you get Android Studio set up and installed on your computer. You won't necessarily need it in order to follow along, but it is highly recommended that you have it. And you could also code in Android Studio even if you want it for a Flutter project. But we're going to be using a different ID or a different text editor. I'll talk about that in a minute. But make sure you go through the install Android Studio steps, get the Android follow the wizard and go through all that process, and then also make sure that you're going to set up a virtual device, go to the AVD manager and set up a virtual device, which is like a simulator but for Android, emulator. And yeah, just make sure you go through this document very thoroughly and complete everything that it tells you to complete. It's going to make your life a whole lot easier so that you don't have to worry about something being broken. All right. Now let's talk about the IDE, or the text editor that I'm going to be using, which is Visual Studio Code, or VS Code. So in order to install this, you're going to want to go to code.visualstudio.com, and you should be able to just download right here. Very simple, very straightforward. We're going to be using this because I feel like the Flutter development environment is much more, I feel like it's superior on VS Code as opposed to Android Studio. If you feel more comfortable with JetBrains IDEs, then feel free to use Android Studio, but I just like Visual Studio Code much better for Flutter development. And then lastly, we're going to head over to rapidapi.com, and this is where we're going to actually be using our API to look up Urban Dictionary terms. So what you do is you're going to go up to the top right and search for Urban Dictionary. You should only get one result. It's this one right here. You click on it, and then it's going to take you over to the Urban Dictionary API, and it's going to give you some information about it. Now, in order to use this API, you will need to sign up. So go ahead and hit sign up right here. and just choose one of the ways to sign up. Very simple, straightforward. So once you're all signed up and signed in, you will now have an API key. You can feel free to use my API key. Just keep in mind that other people might try to use my API key as well, so you may be rate limited and it may not work for you. So I really just recommend that you just sign up and get your own API key. So just to see what this API looks like and the response that we're going to be getting back, you can see that it's going to give us a dictionary which has another dictionary inside of it, which is a list, and we're going to have an array inside of that list. So each of these objects, I'm going to refer to them as terms. So we're going to have a term object that we're going to be decoding from our API, and the different properties that we're going to be accessing are definition, thumbs up, word, and thumbs down. So we're going to be accessing each of those different properties and creating a term object in our Dart code, which is the language that's used to write Flutter apps. Now, if you want to see what this would look like on iOS, you can just go to the code snippet area right here, go to the drop down, go to Swift, and you can do NSURL, and you can kind of get a comparison of what the iOS code would look like when you wrote this natively, just so that you could get a better understanding of what we're actually going to be trying to accomplish in Flutter and Dart. So that's pretty much it. Let's go ahead and open up Visual Studio Code. And at first you should see a window like this when you're first opening up Visual Studio Code. And what we're going to want to do is we're going to want to go to this little extensions area right here, and we're going to want to search for Flutter. We're going to want to download this Flutter plugin. So just make sure that you install it, and then you could also install this snippets. I don't think I'm going to be using that actually in this tutorial, but just make sure that you have this Flutter extension installed on your VS Code, because it's really going to help out with highlighting code. It has a dependency on the Dart plugin as well. And then there's also another setting in here that I want to bring to your attention. So if you go ahead and go to the top and go to, let's see, go down to the bottom left and go to settings, command comma, and you search for guides. I'm going to have these different guides selected. So as you can see here, I have the render indent guides, I have Flutter UI guides, and Flutter UI custom tracking. So after you install those plugins, the Flutter plugins, you should have access to these. You may need to restart your VS Code, but you're going to want to turn these on, because Dart code, and specifically working with Flutter, a lot of the code kind of gets jumbled together, and this makes it a lot easier to read. So that's pretty much it in regards to setup. Now what we're going to do, once we have the Flutter plugin installed, we're going to hit Command Shift and P, and we're going to type in Flutter, and we should see the ability to create a new project. So go ahead and click on that, and then call it whatever you want. You just have to keep in mind that when you're working with Dart and Flutter, you can't use capital letters for naming files. So everything needs to be lowercase, and you can't use hyphens or spaces in the file name. So you have to use underscores. So I'm just going to go ahead and call mine Urban Dictionary. So just like that, and I'm going to hit enter, and it should ask me where I want to put my Flutter project. So go ahead and choose the location. And then it's going to go through, it's going to create all the different files, the native iOS files, the native Android files, and then a couple of other helper files that will essentially get our project all up and running and ready to go. All right, so once Flutter finishes doing its thing and sets up your project in VS Code, you'll actually see that we already have a demo app, which is all commented up, and we have like all this boilerplate code. Now, before we actually delete this, what I want to do is I actually want to make sure that you run your app. So we're going to go up to the top right, and we should be able to hit play. Now, if you don't see this right here, then what you may need to do is you may need to hit Command Shift P, and then you would want to also enter in emulator, or a launch emulator, Flutter launch emulator, and we're going to go ahead and select this one. Then it's going to give you an option for what you want to choose from. In this case, I'll just choose the iOS simulator, and it should connect to my simulator, and then we can go ahead and press play, and it should actually run on the iOS simulator. All right, and then once the app is finally done building, you can actually see that it implements an app. So the boilerplate code that Flutter gives you is this app where it shows you how to just pretty much display something on the screen, and then you have a button where you can tap it and it increments the count. So very simple, very straightforward. And one of the cool features about Flutter that you might have heard about is called hot reloads. So if we actually go over to the function where we're incrementing our count, and we were to change this counter to counter minus minus, so this is the state, this is like a variable that we're changing. We just want to decrement it instead of increment it, and we were to just simply save the file, we'll actually see that we reloaded a file. And if we go back over to our app, you'll notice that the state hasn't changed, so we haven't relaunched the app, but when we hit plus, it's updating to our new code, which is actually pretty cool. And you can kind of see this in action. If I go ahead and close this a little bit, you can kind of see this in action if I go over to the Flutter widget and we change it from a plus. Let's see, we have the icons add. Let's see if there's a icon for minus. Oh, okay, so it's called remove. So the remove icon is what we're looking for. I couldn't find it. So as you can see, I updated the code right here, and we can see that there's still a plus button right here. And if I go ahead and press Command S and save it, you can see that it updated right there. So we still have our state there. We didn't have to relaunch the app, none of that. It's actually very quick. So one of the things that devs really like about Flutter is that it improves or increases their productivity, because you no longer have to wait for your app to rebuild and relaunch in order to see what it looks like when you update a single screen. So you might be able to think of a couple of reasons why that's super beneficial, but yeah, it's called hot reloading, and it's something that we're going to be working with a lot throughout this crash course. So I'm going to actually go ahead and remove all this code with the exception of this first class right here, which is called my app. And I'm also going to remove some of this boilerplate code too, so that we can just start from scratch. All right, so as you can see, we have our app. We removed all the boilerplate code, and let's just go over what's going on here. So we do have a main function. This is obviously the starting point of our app where everything gets kicked off, and it's running this my app object, which you can see right here. Now it extends something called a stateless widget. So there are two different types of widgets in Flutter. We have stateful widgets and we have stateless widgets. If our object is not meant to carry state and hang on to something that's going to be updated, then we're going to be using a stateless widget. If it is meant to hang on to state and update data based off of some type of changes inside of the app or user interactions, then it will be a stateful widget. And we're actually going to see instances of those as we progress. So then whenever we have a stateless widget, we have this function called build. And this function is the first thing that's going to be called whenever this widget is created. So we have this build function, which is kind of like view did load, and all you're pretty much planning on doing here is returning this widget. So as you can see, functions in Dart, this is the programming language that we're using, functions in Dart have their return type prefixed to the name. So it's expecting to return a widget. The name of the function is called build, and then the parameters that are passed in is just context, which is of type build context. So this parameter is being passed in, and we could use context. We're not going to, but we could use context anywhere inside of this function right here. So that being said, as you can see, we have a return on we have the return statement right here, which is returning a material app. And the way that we structure code in Dart and in Flutter is that we pretty much just continue to open up the parentheses and curly braces all in line. So you have the return statement almost always at the top, and then all the logic is almost always inside of the code right here. So it's just like you're constantly creating these different objects and then nesting them inside of each other. So you have this material object, you have this material app, and for theme, you can see that you're passing in a theme data object, and that is being opened up to pass in the visual density. So that's kind of the structure that we're going to be following as we code in Dart. Now, you might have seen as I hover over these different things, you could get the description. So whenever you hover over a type, you're going to get the description of all the different parameters that you can pass into an object. So this will be helpful for whenever you're looking to find out, okay, what types of parameters can I pass in to modify this different widget. So, and also the word widget, you have to think of a widget like a view, a UI view. So widgets are similar to UI views in UIKit, or just views in Swift UI. So that's how you can kind of think of a widget. Now, going down to the material app, you can see that it is taking in a title. Now, the title is only relevant on Android devices. This is something that you would see whenever you're going to like essentially delete the app from memory. So like if you were to swipe and hold up on your iPhone, and then you would be able to see all the different apps that are currently running, that's where you would see this title. It doesn't really have an effect on an iOS device. The theme data, this is just kind of the theme of our app. And as you saw before, we had like a bluish theme to the default app that was provided by Flutter. If we wanted to change the color of our themes, we would just change like the accent color. And then from here, we could just pass in a color by saying colors dot, and you know your boy likes purple. So you can pass in a different color right here, and you can also see the color that you specified if Visual Studio is able to recognize it. So it's able to recognize that we want purple, and that's the exact purple that we're going to be using. From here, we have home, which is going to be returning an object. So we need to actually create a new widget that it's going to return for home. We deleted the original My Home widget or whatever it was called that was displaying the counter app, and now what we need to do is we need to create a new widget that's going to display our new first screen, which is going to be the same screen where we enter in the term that we're going to be searching for from the Urban Dictionary API. So let's go ahead and create a new file, which you can do over here on the left side, and you're just going to want to make sure that you're in the lib folder, and you're going to want to hit this new file icon, and I'm just going to go ahead and call mine enterterm.dart. So as you can see, I called it entertermpage.dart, and when you're working with iOS, you would import UIKit at the top, or if you're working with Swift UI, you would import Swift UI. We have to do something similar for Flutter, and we have to import material.dart. And if you actually use predictive text, it's going to help you out a whole lot here. So make sure you just go ahead and press enter when import comes up, and then just start typing out material, and you should see this package flutter/material.dart, and this is the one that we want. If you don't use text prediction, then you're going to need to make sure that you spell it out exactly like this, or else it won't work. All right, so let's go ahead and create our very first widget, which is going to be our enter term page. All right, so as you can see here, we have a class, and it's called enter term page. So this is going to be kind of like our view controller. You can kind of think about it like that. And we're saying it extends stateful widgets. So this is like saying this in iOS. So as you can see, this would be similar to just having like an enter term VC in UIKit, or maybe like an enter term view in Swift UI, something like that. And we're just saying that it conforms to this stateful widget protocol. So now what we need to do is we need to implement the required function, which is the create state method. So once we have the create state method implemented, and as you can see, we're overriding it and it's returning a state of stateful widget right here, then we're no longer going to have any errors on our screen. But it will throw an exception if you were to try to implement this, because as you can see right here, throw unimplemented error. So this is just to make sure that everything, like all the red squigglies, go away, but we actually need to implement it properly, or else it's just going to throw an error on us, and we don't like them errors, right? So let's go ahead and create a state for our stateful widget page. So as you can see, we created this enter term page state, which extends state, and we're also specifying that we're going to be using enter term page, which is this object that we created up here. Now, if you noticed, it has this underscore right here prefixing the object. And what that means is that it's actually private. So whenever you give a name with a prefix of an underscore, that means that this object is private to this file. So it's similar to using access control, like the private right here, and then we're just doing everything else like this. So class enter term page state, and then it implements a generic state object essentially. Now we do have these red squigglies again, so in order to fix the red squigglies, what we're going to do is we're going to implement the build method. And we're actually a little bit familiar with the build method, as you saw back over here with my app. So we have to do a similar thing as a stateless widget. We have to add this, we have to override this build method, and we're going to add that into our enter term page state now. So once again, got rid of all the red squigglies. Now we have a blue squiggly, and that's just pretty much saying that we never used this object. So are you sure you actually want it? And yes, we do actually want it. So now what we need to do is return our enter term page state. So as you can see, we're returning an instance of our enter term page state object, and yes, you do have to work with semicolons. I'm sorry, but yes, we do. But we're returning an instance of this. Now, when we're doing something very simple, like just simply returning an object or calling a function or anything like that, you can implement it like this, where you have the open and close parentheses, and then just you have like the code block here. But it is actually recommended that you use the arrow. You use the arrow sign instead. So you could do the arrow sign by doing equals and a greater than sign. So when you have those two things together, that's the arrow, and mine may look different than yours simply because I have ligatures on. But this is what it looks like. It's the equals and then the greater than sign, and it's going to essentially run whatever is to the right of the arrow. So this is how it's recommended that you write your code in Dart when you're doing a simple one-liner. So our enter term page is pretty much set up in regards to like the basics, the basic configuration, but we need to still update our enter term page state and make sure that it's not going to be just throwing this error. Now in our enter term page state and inside of this build method specifically, that's where we're going to be using different widgets to build our screen. And once again, widgets are like views. So what we're going to need to do is we're going to need to return a series of different widgets that is going to build our screen and make it look the way that we want. We're going to start off by using our first widget, which is a scaffold. Now a scaffold essentially lays out the screen to be the ideal way for an app, and I'll go a little bit deeper into that after we implement it. So the scaffold is going to allow us to add things like a navigation bar. It's also going to allow us to have a body inside of the main part. So you have a navigation bar at the top, right? And then below the navigation bar is where all the content essentially is, right? And that's called the body. So we need to implement our navigation bar, which is called an app bar, and we also need to give our app bar a title, so we'll do that. And then we're going to need to display something on the screen and below the app bar so that we can actually see what's going on in the app. So let's go ahead and do all those things. Okay, so as you can see, not too much has changed right here. So once again, if you just hover over scaffold, you'll be able to see all the different objects that you could pass in. And let me actually close this real quick. Yeah, if you hover over object, you'll actually be able to see all the different arguments that you could pass in here. So just keep in mind that the type is on the left and the name of that type is on the right. So as you can see, we have body right here, which is of type widget. So we can pass in any type of widget, and just remember widgets are like views. So we could pass in any type of view to this body and it's going to get rendered out. The same thing with the app bar, which you can see right here is kind of being wrapped around, but we're passing in this app bar object right here, and we can do a lot of different things with the app bar, but all I really want to do is pass in a title. And as you can see, the title is expecting a widget. It's not expecting a string, it's expecting a widget. And we're going to pass in a text widget, which is going to have a value of Urban Dictionary. So this should be enough for us to render out the view and kind of see what's going on our screen. Now what we need to do is we need to make sure that we save this. Right now I have this little dot right here, which is indicating that my file hasn't saved. I'm going to do Command S. Everything's saved. It did format the code for me a little bit. It may do that to you too. Just be aware that every time you save the file, it may update the formatting of the code. We're going to go back over to main.dart, which is once again right here on the left side. And for our home, what we're going to actually do is enter in our enter term page. So we're going to go ahead and start typing that. But the problem is that unlike with iOS development, you can't just see all the different objects from all the different files unless you actually import those specific files. So if you actually use the auto correction for selecting enter term page, you're going to see that it should say auto import. And we want to make sure that we do that. So if we select it, now up here at the top, we should be able to see that it's importing from our package enter term page. But let's say we didn't want to do that, right? We could do it manually too and just start typing out import. We're going to use this, and then we're going to start typing out enter term page, and we can do it like that. Either way will work. You just need to make sure that it's imported, or else you won't be able to find this object. So then we're going to initialize our object, and actually let's update the title from Flutter demo to Urban Dictionary app. And once again, that's simply just for Android users, but it's better than Flutter demo. And let's go ahead and run this by pressing this play button, and it should be already detecting our iOS simulator if it's still open right here. So let's open up our simulator, and if you do Command J, you should be able to go to the debug console and then watch as it's building the different processes. So just keep in mind that Flutter does take a long time to run onto devices, much longer than a native iOS app. But once you're running on the iOS app, it's easier to update and see things working. So as you can see here, we have it's a Urban Dictionary, and then it also says Hello World right here. And everything's working as we expect it to so far. All right, so as you can see, it did render out our text widget right here, it did render out our text widget right here, which is the Urban Dictionary that's being said right there, and then it's rendering out the body, which is just another widget. We decided to pass in simply a text widget, so it's going to say Hello World. The only thing that I know that I am missing is that the color isn't correct, and that's because I chose the wrong type of color. It should be swatch color, not accent color. So we want to do primary swatch, and we'll do colors dot purple. So now once again, as you can see, it's blue, but if I go ahead and Command S and save it and go back, it's immediately purple. So that's one of the really cool things about Flutter, is that it just updates so quickly. Alright, so we have stuff on the screen, but now we actually need to get our form put in there so that we can actually start putting stuff on the screen. We need essentially a text field, and we need a button, right? So we need to be able to enter in the term that we're searching for, and we need to be able to hit a button that says search. So let's go back over to our enter term page, right? And right here in our body, we can see that we're rendering out just a text widget, but I don't want to just render out a text widget. I want to do something more advanced. So let's go ahead and create a new function and create a new widget. So as you can see, I created a new function called search form, and what we want to have is a text field and we want to have a button. And in order to do that, what we need to do is we need to have we have to have the text field on top of the button, right? So we need to lay things out vertically. So in order to lay widgets out vertically, what we have to do is we have to use a column. So let's go ahead and implement a column right now. So we have a column which is designed to take in children, and as you can see, we have that children property right there, or the children argument right here, and it's a list of widget. So that's essentially an array of widgets, right? So what we can do is we can go ahead and specify which widgets we want to display under the children. We just need to specify that argument first. So in Dart, you specify an array the same way that you would do it in Swift with the square braces. And now we can just put in a bunch of different widgets, but we only need the text field and we need the button. So let's add those in now. So we have our text field here and we have our flat button, and the column's just going to lay them out from top to bottom. First in is going to be at the top. The last in is going to be towards the bottom. And as you can see here, it takes in two arguments that are mandatory. The first argument is onPressed, so we have some type of function, which you can see here. This is the way that you would kind of implement empty closure, which is a function without a name. So you have the parameters that would be passed into that function. We won't have any parameters passed in, and then the block of code that's going to be executed right here. Right now, we're not executing anything. Then we have a child in order to create the button. So what does the button look like? It's simply just going to be some text, and it's going to say search. So let's go ahead and save our project. And when we go back over to the simulator, it doesn't look like it updated because we haven't called search. So we want to make sure that we do that. So I'm going to make sure that the body is now search form. It's calling our search form function. We save it, and now let's see if we have it updated. And yes, we do have it updated. So as you can see, I'm able to type in right here. The text field is at the top and the search button is right here, but everything looks so dang ugly. Now, the first thing that we want to do is we want to make sure that everything is centered. So what we can do is we could simply look at the different arguments that we could pass into a column, and you can actually see that the main axis alignment can be set. So the main axis alignment when you're working with a column is going to be along whatever the main axis is. So a column is up and down, so the main axis is going to be up and down. If you were working with a row, which is essentially the same thing as a H stack, or a horizontal stack, then it's going to be going left and right. So if we go ahead and specify our main axis alignment to be centered, I think that we should be able to get it to be towards the center of the screen. So I specify main axis alignment, and I want to press save, and let's see. And now you'll notice that the main axis alignment is towards the center. Now we also have a problem because it's just way too stretched out, right? We don't like when it's stressed out. Oh no, we don't. And what we want to do is we want to make sure that we're also respecting safe areas, so that you know, anything with a bezel or with a notch in it, it's going to be respected. It's going to respect that, right? So let's go ahead and make sure we're respecting safe area alignment, and keep in mind that everything in Flutter is a widget. So if we want to respect something like that, we would actually wrap our column in a new widget called safe area. And we can do that by right clicking on column, and we can go down to refactor, or you can hit Control Shift R, and that will refactor, and we can wrap it in a widget. So we could wrap it in a widget that we're going to specify, or sometimes it has some that are already recommended for you. But I'm going to go ahead and wrap it in a widget, and I'm going to say safe area. Then I also want to specify the minimum edge inset, and I want the edges to be on the left and right. So we're going to do symmetric because we want to just do left and right not top and bottom. So we're going to do symmetric, and we're going to say horizontal, and we'll specify that we want it to be 16 from left and 16 from right. So now, as you can see, we have our safe area, which has a minimum edge inset on the left and right, the horizontal, and then it has a child called column. The column has a main axis alignment of center, and the children of a column are the text field and the flat button. So just keep that in mind, that everything is a widget. You're working with a widget tree when you're working in Flutter, and every object, every widget has essentially the capability to have children inside of it. So that's like a very key core concept of working with Flutter, and it's as soon as you're able to like work within that mindset, you're going to be able to go much farther a lot faster. So let's go ahead and save it. Let's take a look at it, and it's looking much better. As you can see, it's no longer touching the left side and the right side, so we're already starting to make progress. But I feel like it's still not exactly what I want, and what I want is I want this to be more towards the center, and not so stretched out essentially. So what we could do is we could just go ahead and wrap it in a widget called center. So let's go back to our column, and let's go ahead and add in some padding. So we're going to refactor it, and we're going to wrap with widget called padding. And as you can see, it's already giving us the default implementation, which is edge inset of 8 from all, which is top, left, right, and bottom. Once again, I don't want all. I just want to have symmetric. And we need to specify that as horizontal. And then we go ahead and specify 20, and we save it. And let's take a look now, and it's looking a little bit better. So you can do that as much as you want to make it stand out however you want. But this looks good enough. I just wanted to show you how to add a little bit of extra padding. We could have also just turned this all the way up to like maybe like 40 or something like that, and then it would have really got smaller. So it just depends on how you want to go about it, but I did want to show that you could add padding or something like that if you wanted. Okay, so now let's go down to our text field, because we need to be able to update the text and then be able to access the value of that text. So how do we do that when we're working with a widget tree? Well, the first thing that you're going to want to pass into your text field is a controller. So we need to hang on to a controller, and this is exactly why we needed to have a stateful widget, is to actually hang on to an instance of our controller. And I just noticed that our widget tree, our search form is outside of our enter page state, and I actually don't want that. So I'm going to cut that. One second, and I'll just go ahead and put this up above right here. So we want our search form to be inside of the enter term page state. So just keep that in mind. But going back to what I was saying, which is our text field and our controller, we are using state specifically because we need to keep track of what's happening inside of our text field, and we need to be able to access that value. So if we weren't doing something like that, if we were simply just displaying stuff to the screen, we wouldn't need a state widget. But since we are displaying stuff to the screen and we need to keep track of the state of the text field, that's why we need a stateful widget, which is our stateful widget right here, which implements state, which is where we're actually doing all of our programming right here. So just keep that in mind. That's why we have to use our state widget. So now let's go ahead and create a new value that we can access, which is going to be our text field's state object. So we have our text field controller, and it's prefixed with the word final. So this is similar to saying let. So this is like let in Swift. And what we're doing is we're creating an instance of our text editing controller. And now what we could do is we could take our text field controller and pass it in as the controller for our text field, like so. And remember that if we're not going to be using this outside of this object, outside of this widget, right, then we want to actually make it private by doing the underscore prefixing the word. So I'm actually going to make it a private constant, or a private final, I guess I should say, because const is also another keyword, but we could talk about that later. But we don't need to access this outside of this object, so we're going to just make it private. So what that allows me to do is now I could create a new function, and I can assign it to my flat button for the on pressed, and we'll actually be able to access the value that was entered into our text field, because any value that is sent into our text field is going to be stored in our text field controller. So let's go ahead and create a new function for our flat button for the on pressed. So above our search form, I'm just going to create a new function just called search. And we're not going to be returning anything, so we're just going to return void right here. It's going to be called search. Once again, don't need access to it outside. We're going to prefix it with underscore to make it private. And all we want to do is print out the value of our text field controller. And since this search has the same function signature as this on pressed method, what we can do is we can once again use the arrow operator to call it. So we'll just say search like that. There we go. So let's go ahead and save it. Let's go back over to our app and run it. All right, here we go. So now when I enter something like this and we hit search, we can actually see that it's printing out whatever we typed in there. So we have a working screen, which is really cool, but it's still looking ugly, right? So a couple of things that I want to change is that when this text field, it does not have anything in it, I want it to also say, like, have like a placeholder or a label that's going to say enter term. And when I have my search button, I want it to be purple. I want it to look a little bit sexy, right? So let's go ahead and update some of those things inside of our search form, starting off with the text field. So let's add in some decoration, and we're gonna pass in an input decoration. And this takes in a label, the label text, and we can specify the label text. And I don't think that I mentioned this before, but it is it's very common to use single quotes to specify strings in Dart. So just another thing that's slightly different. And right here, what we want is enter term, like so. And for our button, we can also specify the background color. And I'll just do it right here. We'll just say color, and we're gonna say, once again, purple accent. So we're gonna use the purple accent right here. We're gonna save it. It formatted my code. It looks like this now. So when we do on pressed, it's gonna call search. When we're gonna specify the color of the button, it's going to be purple. And the child is going to be this text, which says search. We take a look at it, looking a little bit better. Only thing that I don't like is that this search is black, and I think that the text should be white. So let's update that too. And we'll just specify text color to be white. Save it, and as you can see here, looking a whole lot sexier. So looking nice. When I type something in, you can see that we hit search. It enters it in right there, and that's going to be essentially where we're going to be searching for our term. All right, so that was a lot, but we were able to create our first interactive screen. Now what we need to do is we need to actually search our API. But before we do that, we need to have that ability to go to the next screen. So I'm going to start off by creating a widget that's going to represent our next screen. And I'm going to call that terms page, because it's just going to list out all of our terms. So create a new file and call it whatever you want, but I'm going to call mine terms page. That's going to be plural. And remember that we need to import material. And this time we're actually going to be creating a state list widget, because since we're only going to be displaying data and we're not going to be doing anything where we need to hang on to state like we would with the text field, then we can just use a state list widget. Okay, so I didn't do anything really. I just returned this. I created this terms page which extends the stateless widget, and we have to always implement a build on stateless widget or on state, and we need to always return a widget. In this case, I'm just going to return text. Now, keep in mind that there's no scaffold here, so when we see it, it's not going to look as you expected. It's going to be pretty, oh, it's going to be ugly. But that's okay. We're going to get back to that. But I just need to have a different page to show once we're ready to navigate. So let's go ahead and head back over to our main, because now we need to actually set up the navigation. Now, when you're working with UIKit, that's an imperative way of working, and you specify where you're gonna go, and you have the logic determined exactly, like you're specifying exactly where you want the navigation controller to go to, right? And it's very similar in SwiftUI if you're going to be using navigation links, but with Flutter is 100% declarative code, and what I mean by that is you're going to have all of your possibilities in your navigation pretty much specified beforehand, and based off of different conditions, it's just going to pop and push to the navigation stack. So you're going to see what I mean by that in a little bit, but I just wanted to kind of prefix this next part with that statement that we're going to specify all the different pages, and then based off of the logic that changes, it's going to change what our stack looks like automatically for us. So the very first thing that we're going to do is we're going to update the home on our material app, which is once again in our main.dart file, and we're going to change this into a navigator. And the navigator has a property on it, or a parameter that you pass into it, called pages. So we're going to actually be creating what are called material pages, which are going to represent our different screens. That's going to include our enter term page and our terms page, and then later when we create it, our term details page as well. So let's go ahead and implement that pages argument right now. So in order to create pages, what we need to do is we need to create a material page. So let's create a material page that's going to be for our enter term page, which we previously had showing beforehand. So now I have my material page object inside of our pages array, right? And you can see that it does absolutely need a child. So that child is going to be our enter term page. And we also are going to need a key that we're going to be referencing this by. So what I'm going to do, instead of creating this key right here, I'm going to go back over to my enter term page, and I'm going to create a static property that we can access that's going to be, or that's going to represent our key. So let's go back over to enter term page, and then at the top of enter term page right here, make sure it's the enter term page and not the enter term page state, right? We're just going to go ahead and add a static property for our key. So as you can see here, this is how we create a static property. It's static, and this is like let, and this is the name of our static property value key, and it's going to be of type value key, which is taking in a string, which I'm just giving it the same name as as our actual object. So now if I go ahead and save this, go back over to our main.dart file, and I specify the key argument, I can go ahead and enter in the enter term page value key, like so. So the key is the way that we will be able to identify this specific material page and distinguish it between other material pages. So I'm just going to go ahead and do the same exact thing, but for our terms page. So let me go back. I'm going to copy this line of code, this value key line of code from our enter term page. I'm going to go to our terms page.dart, and then at the top, I'm just going to go ahead and paste this in, and I'm going to update the value key to be terms page, like that. So this is, like I said, once again, going to allow us to distinguish between those two. So when I save it and update the formatting, you can see this is what it looks like now under our pages argument. Let's go ahead and add in another page for our terms page, or yeah, for our terms page. All right, so as you can see, I implemented my terms page right here as a material page, and I used the autocomplete, which imported the terms page for me. So make sure that you import it at the top. And for the key, I'm just passing in the value key, and for the child, it's the terms page. Now, the last argument that we absolutely need for our navigator is the did pop, or on pop page. This argument, which is also taking in a closure, and it is going to be passing two different arguments. So we need to specify the route and the result. And just so that it's going to continue to do the same thing that it's implemented by default, we need to just return route.didPop and then pass in the result like so. There we go. So now if we go ahead and save our app and take a look at it, we're going to notice that we have this terms page. And like I said, it was really ugly. And the reason why it looks like this is because notice that we have this navigator and this pages, right? And it works kind of like a stack. So the material page is the first thing, the enter term page is the first thing that we're putting into our stack. And then the terms page is the second thing that we're putting into our stack, which means that the terms page is now currently on top. And the reason why it looks like this is because if you remember, in the terms page, we just implemented text. And by default, text just looks like this really ugly thing. So what we want to do is we want to modify this to look better. But before we do that, we need to understand that we don't have any logic to dictate when the terms page is supposed to actually show. So we need to change it so that we're only showing this terms page based off of specific logic. And that logic is that we actually, in our enter term page, we typed something in and then we hit search. And now we have this value that needs to be searched. So what we're going to do is we're going to actually update our enter term page to take in essentially like a closure. It's going to be called a value changed type, and we're going to pass in that closure so that we know whenever that value gets called, or whenever that value gets updated, that closure gets called, we can actually update our state inside of our my app. Now, and remember, if we're going to be changing state or hanging on to state, we can't be working with a stateless widget. So that means that we actually have to make a change on my app as well. So what we're going to do is we're going to change my app into a stateful widget. And then we're going to need to move our build function over to a state object. So let's go ahead and do that right now. All right, so the first change is done. We have our my app converted to a stateful widget, and we took that build method and put it in this new object called my app state, which once again, it's private, and that extends state of type my app, and I just pasted it in here. So not too much has changed. Other than I copied and pasted the build method into my app state, and then we created this override method, which is the create state, and we created my instance of my app state. So that's all that's changed so far. Now what we need to do is we need to we need to have an instance of the string that we're going to be searching for. So let's go ahead and create a variable for that. All right, so we have our searched term, and we're also going to need to have a handler for the closure that we're going to be passing into the enter term page in a second. So let's go ahead and create a function for that as well. All right, so I created another function called search for term, and then it's expecting a string to be passed in. We'll be referring to that string as term right here. and we're going to be updating this dot search term, which once again we created that up here, and this is just kind of like self, so it's kind of like this. So this is what it would look like in Swift. Self.search term is equal to term. That's just how you think about this. And we're updating it to whatever's passed in. Then I'm also printing it here. So now let's go over to our enter term page. Let's create an argument that can be passed in that will essentially allow us to handle whenever they pass a search term to us. So let's save this. Let's go to enter term page, and we're going to be expecting a property to come in that is of type value changed. All right, so as you can see, I created this new property which is going to be passed in. It's going to be of type value changed. So value changed is kind of like a closure. You can kind of think about it like that. And the type that's going to be passed into that closure is going to be a string. It's very similar to this in Swift. So this is what it would kind of look like in Swift. It would just be similar to a closure. So we have it here, but we're not actually specifying how to pass in the value, because we need to actually create the initializer for our enter term page now that we have a property that needs to be filled or initialized. So now what we need to do is we need to create an initializer, and we do that like this. So this is how you would create an initializer for your objects. You specify the name of the object, and then you open and close the parentheses, and depending on if you put curly braces in here or not will determine how you're actually able to call the initializer. If you have curly braces in here, then what you'll actually be able to do is you'll be able to pass in this property with the name. So you'll be able to call the function or call the initializer by name. If you didn't have this, which this would be perfectly fine too, but if you didn't have this, then what would happen is you wouldn't actually be able to, you wouldn't know which name that you're calling them, which name you're passing the parameter to on the call site. So you would have to just memorize and make sure that you enter it in the correct order. So I just want to make sure that this initializer has those curly braces right here, and I forgot the semicolon, so I just added it in right there. Now there is another parameter that you have to pass when you're actually creating instances of widgets. So what we need to do is we actually need to pass in a key as an argument as well, and then we also need to initialize the superclass up for that key as well. So we'll just go ahead and call super, and we'll pass in the key that was passed in right here. So Flutter is going to handle this for us. We don't really have to do anything there, but we do need to make sure that we're passing in a key so that we have unique instances of this enter term page. And I'm also going to just prefix this with final just so that we can get this enter term page to stop going with that blue squiggly. So since we're actually not going to be updating this value, this search for term, we can mark it with final or kind of like let. So now we need to actually access the search for term like value changed property inside of our state. And keep in mind that these are two different objects, right? So normally you don't actually have access, you don't have access in between or outside of this scope, right? So we're defining search for term in this scope, which means that it can only be seen from right here, right? But when we're actually doing the stateful widgets and we're extending the state, since we're passing in the type of state that we're going to be working with, in this case the enter term page, the way that we can access the properties that are inside of the stateful widget is by accessing the property called widget. So right here on our search function, we can access the search for term value change property by saying widget dot search for term. So now you can see here we're both printing out the text field controller's text property as well as passing that same property to the search for term function or the value changed property. So we're going to send the text field text here. It's going to go up to our enter term page, and it's going to update right here in our search for term. And since it's like a closure, we're going to essentially be calling it back over here in the enter term page. Now we haven't implemented that part yet, but when we do, what we're going to do is we're going to pass in this search for term function as the value for that search for term value changed property. So let's go ahead and add that right now. All right, so as you can see, we have the search for term entered in right here for our enter term page. So this is our enter term page right here, and we're passing in the search for term. And I think the problem right here is that we're actually using it before we created it. So Dart is one of those languages where you need to actually specify that you have to implement the thing before you actually use it. So now in our enter term page, we can pass in the search for term, and we're passing in that function, which is search for term. And once again, let's go ahead and make this private as well, since we won't be using this outside of this class. So we have search for term, and it's going to be passing in the term that's passed in from our enter term page. We're going to be updating the property called searched term right here. And we're also going to be printing out that term. So let's go back over to our enter term page. And I want to remove this print statement just so that we don't see it printing out twice. I just want to make sure that it's only printing out right here in our search for term page, or search for term function. So let's run that. And we'll also go down and comment out the other page that we have implemented, our other material page that we have implemented, which is our terms page. So let's just keep this commented out for right now. We're going to reload the app, and we should be able to see our search for term, our enter term page. So now if I go ahead and enter a term, say hello, and I hit search, we can see that it's still printing out hello. So really good stuff. We were able to send data all the way up the ladder into my app state. And now, since we have search term being updated right here, right? Now we can actually add in some logic to make sure that we only show this material page, the terms page, if we have a value for searched term. So let's go ahead and update that, update our pages array, and make sure that it's only showing this material page if there's data in there. All right, so let's take a look at what I changed here. So I started adding some comments because things are starting to get jumbled together, and that's why I recommended that we had these lines on, so it's a little bit easier to read. So our first item in the stack is going to be the material page, which is our enter term page. So we should always have that at the very base and always showing no matter what. Now, if we are able to fulfill this condition, and you make condition statements by doing if and then wrapping the condition in parentheses, then what we need to do is we need to check if search term is not equal to null, or make sure that it's not equal to nil essentially, and we want to make sure that it's not empty. So not only does search term need to have some type of value, it also can't be empty. It can't just be an empty string, right? So if those two conditions are true, and it's important that you kind of keep note that there is no open curly brace when you're doing if statement inside of an array. That's one really cool thing about Dart. You can do if statements inside of arrays, but you don't use curly braces when you do it. Anyways, if this is true, if we do have some type of searched term, then what we're going to do is we're going to display our terms page. So let's go ahead and restart our app real quick. And I think I need to stop it so that there's actually no data saved to it. Because remember, when you refresh your app, it will hang on to the state and it won't necessarily just erase that data from memory. All right, so as you can see, we're starting with a fresh build, and when I search for hello, and I search, now we have hello updated here, but it looks like nothing updated right here. So one of the problems that we have is that we did change the value of searched term, right? But we actually didn't update the state. Now, what you have to do to update the state is we have to go back up to our search for terms, and whenever you're changing one of the values that are updating the actual state, we need to wrap it in a function called setState. So as you can see here, we have our this.search term equal to term still, but now it's wrapped in this setState function. So let's go ahead and reload our app. And now when we go ahead and enter in hello and we hit search, we see that our state is actually updated and we're pushed back to this very ugly screen. And that's because, once again, our terms page is not set up yet. So that's a pretty huge accomplishment. We were able to implement some navigation, and now you can see that we want to make sure that our navigation stack is all set up when we're only navigating when certain conditions become true. So we have our material page, and then unless this condition is changed to true, then we're not going to show this. But once it does change to true, once we have our search term equal to some type of real value, then the material page will now be brought onto the stack. So with that said and done, let's go ahead and update our terms page. So I'm going to go ahead and start off by making a scaffold for this page. Alright, so as you can see, I created a scaffold and I simply added an app bar. So if we go ahead and save it, now we can see that it says terms, and then we get the navigation bar, which automatically allows us to go back. And then we can go forward again. So we're getting some navigation down, really cool. But we don't want this to say terms, we want it to say the actual word that we searched for. So what we need to do is we need to update the parameters that we're passing into our terms page, and we need to make sure that we're passing in the actual term that we're searching for. Alright, so as you can see, we implemented our initializer. Once again, make sure you keep key in there, and then you're adding the super key. So we need to be able to pass in a term. In this case, I'm referring to the term as just like the string term that we're passing in. And that term is going to be, or we can actually change this to title so that there's no confusion. So that title is going to be what we need to pass into the title right here for the text. There we go. Let's go ahead and save it. And let's go back to our app, and we can see that this is no longer working because we're not able to create a terms page without passing in these arguments. So let's go back to our main.dart file, and let's go ahead and pass in a title, and that title is going to be the searched term. So after it formatted itself, we're going to still be creating our terms page, and for the title we're passing in the searched term, which we don't have any problems with since we're checking to make sure that it's not an optional value, not null, and that it does actually have some type of value inside of it. So now let's go back, take a look at our app, and it says hello, looking good. And then let's go ahead and enter something different in there, like kilo, and it says kilo. So making progress. Heading back over to our terms page, next what we want to do is we want to create a list widget. So let's go ahead and create a new function for that. Alright, so we have this new function which is going to return a widget, and what we want to do is we want to create a list, but we have to keep in mind that our list may be dynamic. It's not going to be, but I'm going to show you how to implement it if it was dynamic, and we need to do that by using a list view and builder. So let's go ahead and implement a list view builder. So a list view builder, as you can see, it's of type list view, and you could technically just create a list view with some static items in there, and we could technically do this because we're going to actually be fetching the terms outside of here, but I want to show you how to do the easiest way to create a dynamic list, and probably the best way to just memorize instead of just doing it the static way. So what we have to do to create a list builder is actually create a build context, and you create a build context by simply doing a closure like so. So we need to pass in a context and an index. So the context, we're not going to be really using it, but the index essentially allows us to access the specific term that we're going to be working with. So if we tapped on something or something like that. Now we also need to implement the items count. So let's add that in as well. So item count, and we need to pass in a number. Right now I'm just going to do 0 because we don't have an array in here or a list in here that we can reference, but this is where we're going to actually be specifying how big is our list. So in order for us to actually use the proper array count, let's go ahead and also add in a new property into our initializer, which will take in a list of terms. But before we do that, we actually need to create the term object itself. So let's create a new file called term. Unfortunately, Dart doesn't have structs, so we're just going to go ahead and create a class. And then we're going to implement all the different properties that we know that we're going to need. So we need the word, we need the definition, we need the thumbs up and the thumbs down as well. But instead of using the words thumbs up and thumbs down, I'm actually going to choose to use likes and dislikes just so that I can show you how to decode different names a little bit later. So let's go ahead and add those properties in now. All right, so we have a word, we have a definition, we have an integer. Make sure that you pay attention that these are lowercase ints, and likes and dislikes. So now if we save this, we can go ahead and create a list of terms that can be passed in here. And I did use autocomplete, so it did import the term.dart file for me. Just make sure that you do that. And then we need to update our initializer as well to make sure that we're passing in a list. So let's do that now. All right, perfect. So we updated our initializer. That means that we need to go back over to our main.dart file and update the call site as well. So we'll just go ahead and add in terms, and we can specify an empty array right now. We'll save it, go back over to the terms page itself. And now instead of in our item count being 0, we can do terms.length, which is similar to terms.count. All right, perfect. So now we're going to actually be working with the array of terms that's passed into our widget. But what we need to do is we need to render out what this list view is actually going to display, because we're specifying that we're going to be using a list view, which is just the table view, but we haven't specified what each row is going to look like. So we need to essentially create a cell, and we need to lay that out. We need to use whatever widgets we want in order to create that cell. So let's go ahead and start off with a list item, and it's going to have a title, and we can pass in any widget we want, but the title is just going to be text. And what we can do is we can use the index to determine which term we're specifying here. So let's go ahead and access or create a term. So we have a final term, which is just going to be equal to whatever term is at that specific index, and then we'll pass in the term dot word right here, like so. And then we just want to make sure that we are returning our list tile so it knows which view we're actually returning. So we update that, and as you can see, it formatted again. So once again, item count is terms.length. Our item builder is taking in a closure, which is going to pass in the context, and an index. We won't be needing the context. We could just do this. That's perfectly fine as well. But we will need the index. So now we access the specific term, and then we return a list tile, which is going to have a title of text. Now, a list tile also has a subtitle, which we can access too. So let's go ahead and add that in now. And now, as you can see, we have our list tile, which the title is once again the word, and the subtitle is going to be a definition. So let's go ahead and go back up to our main.dart, because now we actually need to pass in a couple of terms, or at least one, so we can see what it looks like. And I just realized that we created the term object without an initializer. So we have the term in here, but we actually didn't create an initializer. Let's go ahead and create our initializer. All right, so we created our initializer, and once again, we're just gonna say we're gonna be using the curly braces so that we can get the named arguments, and just specifying each property with this dot, whatever the property name is, we'll pass it into the correct property value. So let's go ahead and create a new term, a dummy term right here. Alright, so as you can see here, I created a new term, and I actually didn't have it imported at the top, so I made sure to go back at the top and import it. And as you can see here, we just created a new dummy term. So now if we save it, we go back over to our area and we save. We're actually not seeing anything, so let's go ahead and make sure that we go back to our terms page, and we want to make sure that our terms list is actually being called in the body of our scaffold, which is going to be right here, and we want to have terms list like so. So let's go ahead and save that, and now we can actually see that we have our term looking pretty good. That's all right, but I think I want it to look a little bit, just a little bit sexier, and we can do that by going back up to our list title, and we can wrap it in a new widget. I'm going to actually use the shortcut, which is Control-Shift-R, and that's going to bring up which widgets I could wrap it in. None of these are the ones that I want, so I'm going to wrap with a random widget. In this case, I'm just going to use a card widget. So now if I go ahead and save it, it formats again, and we take a look at our widget, and it looks a little bit nicer. It has like these rounded edges and things like that on it. And we probably need to conform to the safe area, especially since it's going to be a list. So let's go ahead and wrap our list view in, or actually we don't even have to do it there. We could wrap it right here. Let's go ahead and wrap our terms list in a safe area. So Control-Shift-R again, and I'll wrap in a random widget of my choice. And in this case, I'm going to do safe area. So now I save it one more time, and it didn't really update because I didn't specify the minimum. So let's go ahead and specify that minimum. And we want to specify the edge insets, and we want the symmetric horizontal to be 16. Save it one more time, and now you can see that there is like a good amount of space between the left and right side. So really good. Really easy to actually implement if you ask me. Next, what we want to do is we want to actually be able to tap our list tile and then go to the details, right? So we should be able to tap on this dummy term and then make something happen. So our list tile, as you can see, has an on tap function right here. So let's go ahead and implement that. And when what we're going to do for right now is we're simply going to print the term.word, and we'll save. Let's go back over to our app. We'll tap on it, and you can see that it gives us a little bit of an animation, and we actually get the print out right here. So for dummy term. All right, perfect. So we have this page pretty much all laid out exactly how we want it. Now, what we need to remember is that we're going to do some type of navigation when we tap on this tile, right? So that means that we need to update the state back over in our main, inside of our my app state specifically, and we need to update the navigator. We need to see the pages. We need to update which page is showing, and we're going to do that with some different condition. So let's go ahead and create our term details page first before we actually update this logic, and then we'll actually be able to implement a new material page that is blocked by some type of if statement, which will show only when that statement is true. So I'm going to go back over here. I'm going to create a new file, and I'm going to call it terms details page. All right, so this is going to be another stateless widget. So let's go ahead and import material. All right, so we have our term details page here, and it extends a stateless widget, and we don't have anything implemented in here. So instead of just implementing text here like we did last time and have something really nasty, let's just go ahead and implement a scaffold that's going to also have the title of whichever term we selected. All right, so a couple of things that I added in here. I added the scaffold, which has an app bar, and the app bar has a title of which takes in a text, or takes in a widget. We chose text, and I'm simply going to be using the term .word in the app bar as the title. So in our initializer of the term details page, once again, we're passing in that key. We're passing in a specific term. At this point, we should have the term that was selected. And then we have a property to save that term to, which is of type term. So that's all we have going on right here. Let's go back over to our main.dart file, and now we can actually add in that logic. So what we want to do is we want to make sure that whenever we have a term that's selected, we save that somewhere inside of our app state. So now we need to create a new property called saved or selected term. So that's going to be our selected term. Now what we need to do is we need to be able to update this from our terms list. So what we're going to do is we're going to have a function just the same exact way that we have right here when we're grabbing the value or passing in a value changed to our enter terms. We're going to pass in a value changed to our terms list, or our terms page, I mean. So let's go ahead and create another function here. All right, so as you can see here, we have our did select term function, which is taking in a term. And right off the bat, I want to make sure that I'm setting the state. So whenever this gets updated, whenever this function gets called, I'm going to make sure that this change right here is inside of set state, so that our state updates and our navigator will be updated and notified as well. So we're simply just setting the selected term here, and then let's also print which term was selected. So now we have that in there as well. So we need to actually send this function or call this function through our terms list page, or our terms page. So now back at our terms page, we need to add in another property. So let's go back over to our terms page. And here is so we have a final value changed term called did select term. Once again, this is kind of like a closure. And then we need to also be passing that in through the initializer. So let's do that. And since this is a stateless widget, we don't need to actually pass this through to a state. So we obviously have access to the did select term. And all we need to do is in here in the on tap, instead of calling print, we can simply call did select term, and we can use our arrow function as well, just like that. So when we tap on our list tile, we're going to call this function right here, which is going to pass in the term that was used to populate the title and the subtitle as well. So let's go ahead and save that. And if we go back over to our main.dart, we should need to pass in the did select term argument, and we're going to use our function called did select term, like that, just like that. We don't need to specify an argument because the function signature matches exactly. So if we save it, And if we go back over here to our list and we clear this out, and now we select the term, we see that we're printing out an instance of the term. So it's not going to print out the term exactly, but if we wanted to change this to maybe just like the word, if we wanted to print out the word, we could do that. So let's go ahead and tap it now, and we can see that dummy term is printed to the console. So now we're pretty much ready to actually handle whenever this searched term or the selected term is changed, right? So whenever that has a value, we can update our navigator. So let's go ahead and add in some functionality that's going to make it so that we're able to show our term details page, whenever our selected term has a value. All right, so as you can see, first, make sure that you have this comma in here. I didn't see it at first, but at the end of the material page, which is presenting our terms page, we need to have a comma at the very end because once again, we're still in an array. So we want to make sure that we're doing that. Then I have this if statement, which is checking, is the selected term equal to null? If it is not equal to null, then we're going to show this new material page, which is this term details page. Now, keep in mind that we are missing an argument here, which is the key. So let's go back over to our term details page, and let's also make sure that we're passing in a value key the same way that we're doing it for the terms page and the enter terms page. So heading back over to my term details page, or actually let's go to the terms page, we'll copy this, we'll save us a little bit of time, and we're going to put it right here at the top, and we just want to make sure that it's term details page like so. So now we have a value key that we can use to identify which type of material page this is, and we'll just go ahead and pass that in. All right, and as you can see, we're passing in the term details page value key, and we're creating the term details page as a child. So let's go ahead and save that. We go back over, and now you can see that our view has already updated. But if we wanted to do this again, we can say, oh hi, we go, and now it's actually creating, it's pushing us all the way to our dummy term, so our term details page. Now this isn't exactly right, but it will work on the first run. So if we actually restart our app to a fresh build, and let's go ahead and stop this, and we'll run it again. All right, so we have a fresh build, and if we go ahead and type in Hecko instead of hello, let's just do something different, right? And we hit search, then we don't currently have a selected term, so it's not going to show us that right now. So if we go ahead and hit dummy term, then it does select the dummy term. Now our selected term has a value, and it shows our details screen. So let's go ahead and build out this detail screen, and then we're going to take care of some of the navigation parts. So I'm going to head back over to the term details page, and let's go ahead and create a separate function for the way that we're going to implement our widget. So let's create a function called details, term details. And what we want to show are the definition, and we also want to show the likes and the dislikes. So let's go ahead and start off with the column, because we're going to need to have a text widget display our definition, and then below the text widget at the very bottom, we're going to need two other text widgets to show the likes and the dislikes. All right, so as you can see, a couple of different things are going on here. So we have our column, and our column has children, right? It could take in multiple widgets for children. So the first widget that we're going to have at the top is going to be a term or a text widget, which is going to display our term.definition, right? And then our row is going, and then we're going to have a row, which is another widget that's similar to column, except it's horizontal, right? So from left to right. And it also has, it takes in children, and it takes in multiple widgets. And we have a text widget that's going to display the likes, and then another text widget which is going to display the dislikes. So let's go ahead and save this and take a look at what this looks like. And it did format again, just don't freak out. So once again, so we have a text widget and a row, and then the children for the row are the two text widgets like so. So let's go ahead and take a look at what that looks like. And we get nothing because once again, I forgot to call it. So let's go ahead and update the body of our scaffold. All right, so now we should get an update. And as you can see, it's showing the definition. So dummy term, a fake term, and then we have the likes and dislikes. So we got everything on the screen, but it looks so freaking ugly. So let's go ahead and update that. The first thing that I want to do is I want to make space between the definition and the likes and dislikes, because the likes and dislikes, I want them all the way at the bottom. So we can do that with the spacer. All right, I just added a spacer as one of the children in my column, and I put it in between the text of the definition and the row widget. So if we take a look at that, we can see that the definition is still at the top, and we have the likes and the dislikes all the way at the very bottom. So I don't really like that. So let's go ahead and wrap this in a safe area. So we have it wrapped in a safe area. We also need to specify the minimum. And this time I'm gonna just do all, because I want there to be a safe area between all of them. So let's go ahead and take a look at what that looks like. So looking a little bit better. So now we have the definition up here, and then we have the likes and dislikes here. The other thing that I don't like, look at how close the likes are to the dislikes. Let's go ahead and add another spacer. So going back up to the terms details in between the two text widgets, let's just go ahead and add another spacer like so. Or actually we can use padding instead. So let's use padding because we don't want to push them all the way apart. And padding takes in edge insets. And we'll just say all, and we'll just say something like 16 or something like that. And we need to add a comma there. And now we have our text inside of our row, the children inside of our row, a text which shows the likes. We have a padding in between those likes and those dislikes. And if we take a look, we get pretty good space. Let's lower that to maybe like 8, because it's doing 16 in all directions, and that's looking a whole lot better. So I like that. Last thing that I want to do is I just want to make sure that this text widget is all the way to the left. So let's go ahead, and this time we're going to update the column, and we're going to change the cross-axis alignment. So remember, we don't want the main axis alignment, because the main axis alignment of a column is going to be up and down. So that's the main axis, and if I were to say start, then it would just stay at the top, because that's the start of the main axis, right? But what we want is the cross-axis alignment of the column, which is going to be start is going to be at the left. So let's go ahead and add that in. So we updated the cross-axis alignment with cross-axis alignment.start. We save it, and as you can see, it's looking pretty good. So we have all of our UI pretty much laid out, and everything's looking, you know, relatively decent. I mean, it's not the sexiest of sexy, but it's all right, right? So now let's remember that we have this problem that if, let's say we go back and then we save some change, right? And then we go back over to our app, it takes us back to the detail screen. And the reason why it takes us back to the detail screen is because, remember, we now have a selected term back over here in our main. So even though we go back, we never actually specify inside of my app state that the selected term needs to be returned to null. So that's causing it to stay in memory, and whenever we reload our widget tree, what's happening is our navigator is saying, oh, there is a value for the selected term, so that means that I'm supposed to display this widget right here. So what we need to do is in our on pop page, we need to actually make sure that we change the selected term to null. And we're going to also need to do the same exact thing for search term when we do back on that route too. So let's go ahead and add in some conditional statements that will set each of those terms to null respectively. Alright, so before I actually implement this logic, I just wanted to point out that in our on-pop page of our navigator, that's where we're at right now, in our on-pop page of navigator, we have access to the route. And the route has a property on it called settings. And the settings is actually going to be the material page that we passed into our navigator. So it's going to be each of these material page type objects, right? And this is why we actually added and specified a page key that we can reference multiple times. So remember that we have term details page dot value key. Well, that key is right here, and we're able to access the page key. So now I can check, okay, is the page key equal to term details page dot value key? If it is, then I'm gonna set the selected term to null. If the page key is equal to the terms page value key, then I'm gonna set the searched term to null. So that's kind of the idea behind the logic that we're about to implement. All right, so as you can see here in this if statement, in these two if statements I have here, what I'm doing is if the page key that's coming from the route that's being popped, if that page key is equal to the terms page key, value key, then we're going to set the searched term to null. And remember that we don't have to do set state here because the UI is already updating. It's already pushing the view backwards, right, in the navigator. It's already showing that we're going back. It's just that under the hood, the state is not being updated automatically, and that's what we're doing here. So we're just modifying the state to reflect what is happening on the screen. So that's why we don't have to do set state here. But we're just setting the search term to null. And then if the view that's being popped is the term details page, then that means that the selected term is now null and we can select a different term. So now if we go ahead and save this, go back, and if we go back on the screen and I save it again, when I go back to my app, I should see that we're not going to be automatically pushed to the details page. So we have all of our navigation set up. We did all of our UI. We're able to pass the value that's entered here to this screen, the value that's selected here to this screen, and display everything. Our UI is completely set up. The last thing that we have to do is we need to tie this to the API, the Urban Dictionary API, so that it is actually loading the correct terms in here and not just loading our dummy term. All right, so in order for us to actually start doing networking requests and go out to the internet and get data, we're going to have to install a package. Now we do that by going over here to this pubspec.yaml file, and as you can see, there's a lot of there are a lot of comments in here. But if you go ahead and scroll down, you're actually going to see that we have a couple of dependencies in here already. Flutter being one of them, and the Cupertino icons, which is Cupertino is just pretty much saying Apple. So the Apple icons are also added in here. So now what we want to do is we want to add another package in order to be able to make those networking requests. So in order to find the package that we're going to use, we can go over to pub.dev. And if we search for HTTP, which is the networking package, you can see that it is right here. So we're going to go ahead and click on this. and we're going to go to installing. Now you can kind of think of this HTTP package as a URL session essentially. So URL session isn't something that's baked into Dart and Flutter. It's something that you have to actually install as a package. And you can see right here in the installing instructions, we have to enter in this line of code into our pubspec.yaml file. So I'm gonna just go ahead and paste this in right here. And as you can see, it's specifying the name of the package, which is HTTP. And then we have this caret right here, which is essentially saying up to and leading to the next major version. So everything below essentially 1.0 in this particular use case. Same thing goes for right here for the Cupertino icons. I believe it's saying up to anything up to 2.0, because when you have a major version release, what that usually represents are code breaking changes. So that's why we have this caret right here. It's kind of like Swift Package Manager in that way. And I'm going to be using 12.2. You might be using something newer depending on when you're watching this video. So once we have that in there, I'm just going to do Command S to save. And you're going to see that it's going out and downloading that package. It's really quick to get it in there. And once we have it in, we can now create a new file, which is going to be for our networking service. So let's go ahead and create that new file and call it networking service. And I actually want to move this into my lib folder. So let's go ahead and move that. And I also forgot to add the .dart extension, so I need to rename it. There we go. So now we have our networking service file. So let's go ahead and import HTTP and create a new class called networking service. So as you can see here, we have our networking service class, and I'm also importing the HTTP package. And you can also see that I'm casting this package as a name right here. So it's essentially defining a variable of how do we want to interact with this package. You can literally call it whatever you want, but it's very common practice to cast packages as a specific name. And you can also follow along in the README that it also recommends that you cast it as HTTP and then use HTTP directly in your code. So just keep that in mind. So we're only going to have one networking call in here, which is going to be define term, and we're going to need to pass in some type of string. So let's go ahead and create that function real quick. All right, so as you can see, we have a new function called define term, and I'm passing in a search term, which is of type string. And right now I have it returning void. Now, what we actually want to return from this function, because in Dart we don't necessarily use callbacks or closures usually to return a result. Dart actually provides a very nice inline way to use asynchronous code. So what we actually want is a future, and a future is an object that you don't necessarily have access to. You can kind of see a similarity in Swift UI if you've played with futures and promises there. It's pretty much a very similar thing, just implemented a little bit different. So we want a future, and we're expecting to define this term and get back an array of terms. So we're expecting to get back a future list of terms. So a future array of terms. So let's go ahead and update the return value. And just one reminder in case there was any confusion here, a list is similar to an array, but a list view, which is what we used to display those terms, is a view. It's not like a data structure. So just throwing that out there in case there was any confusion. Now you can also see that I don't have the word term right here. Now, if you want to easily fix that, you could just do this little quick fix right here. You could click on this button or do Command period. And here we can see import library, and we can get our term.dart file added in there. Very nice. Oh yeah. So let's talk about what needs to happen. First, we need to actually have our search term converted into query parameters. And you can see that here, if we go back over to Rapid API, here we go. You can see that here we're going to be making a URL request. So let me change it to Swift. We're going to be making a URL request, and the string, the URL is going to look like this. So we have the URL, which is this right here, and we have the path that we're going to actually be querying, and then we have the query parameters that are passed in after the question mark. So what we want to do here is we want to break it up into what is the base URL. In this case, it's going to be this mashape community urban dictionary.p.r or rapid. It's going to be all this. I'm not going to read it out to you. It's going to be all this. So let's go ahead and copy that, and we're going to use that in a bit, and I'll put it right there in a comment. So that's going to be our URL. Then we have the path. So we just are going to copy and paste because I don't want to have any misspellings. And then we have the term. So this is going to be the key of the query parameter, like that. Two other important pieces of information, and let me just go ahead and log in real quick. So the two other important pieces of information are the headers. So we are going to need to add this in there as a header. So we'll add this. And then our API key, which is right here. So we need to add all this information and create a query with everything that's given right here. Voila. Okay. So if you were to do this in Swift, I mean, they don't necessarily have the best practices in Swift. You would probably want to use query parameters. But another thing is, like, I just want to point out is that we're going to need to do this GET request. We're going to need to add in the headers into the request. And then we need to make sure that we have the correct path and we're passing in the query terms. And we need to bundle all that together and then make the request so that we can hit our API. So let's go ahead and start building out our each of these pieces that we need to implement. So the first thing that we're going to do is we're going to build the query parameters. So we have our query parameters, and then this is how you define a dictionary, or kind of like sometimes referred to as an object. So you can create a dictionary by using the curly braces, and you just simply create a dictionary just like normal after that. So instead of the square braces that like we use in Swift, we would actually use curly braces instead. Next, what we want to do is we want to bundle up the base URL, the path that we're going to be calling, and add in these query parameters at the end. So what we need to do is make a URI. All right, so I wanted to show you this before it starts formatting itself. In order to create a URI, what we need to do is we need to do URI.https, and we want to make sure that we are going to pass in the base URL first. So that's the very first thing. We don't want to add in the HTTP : / part. We just want to add in the base URL by itself. Then specify which path we're going to be using. So once again, define, and then we're going to pass in those query parameters. So if I go ahead and save it, it's going to reformat it. It's going to reformat itself to look like this. But now that we have our URI, what we can do is we can actually perform the GET request. Oh, but before we do the GET request, we also need to add in the headers. So let's go ahead and do that first. All right, and there we have it. We have our headers, and as you can see, we have this X Rapid API host, and it's essentially specifying the host or the base URL. And then we have this X Rapid API key, and this is going to be your unique key. So this is the part where you kind of need it to create your own account, or else this may not work, especially if you try to use mine. So now we have everything that we need in order to make our request, and it should be giving us a response. So let's go ahead and get that request. So as you can see, we have our response, and we're going to be getting a response from calling our HTTP. Once again, that's what we called it up here at the top. So it's grabbing it from the HTTP package, and then we're calling .get. We're going to specify the URI, which we created right here. And then we're passing in our headers, which we specified right here. Now, you're going to notice this await keyword, and await allows us to do asynchronous operations, but it allows us to do it inline so that we're able to essentially write code and not have to deal with closures. So it's actually a really nice feature, because this essentially turns into a future response. Like whatever is going to be coming out of the other end of this, it's going to wait until this networking request gets a value and comes back, and then that's what the response is going to be. So that's what await does. But you're going to see that it has a red squiggly under it, and we don't like those red squigglies. So in order to get rid of the red squiggly, we have to specify that this is an async function. So we're going to use the keyword async right here. So asynchronous function, right? And now we have await without the red squiggly. So all we have to do now is just check if we got a successful response, and just like any other HTTP request, the way to check if you have a successful response is if you have a status code of 200. If we don't have a status code of 200, we're just gonna throw an error right in the user's face, and we're gonna blow up the app, because we're not handling errors today. So let's go ahead and write that code right now. All right, so as I said before, our response has a status code. If that status code is equal to 200, we did something right. If it's anything else, we did something wrong, boom, goes the dynamite. So nothing's going to work after that. It's going to kill the app. So in our success block, what we want to do is now we want to get the response body. So what was actually returned, not the status code, but the actual data itself. And we want to turn that into our objects. So we want to turn it into a list of terms. But we have to keep in mind that if we take a look at the code, or if we take a look at our response, what happens is we're not actually going to get a list of terms. It's not just going to be an array of terms. It's actually going to be a dictionary with only one key in there called list, and then we have an array of terms. So we're going to have to create a separate object to handle the response. So we're going to have a define response object, a define term response object, and that's going to allow us to parse out that list and get the array of terms, and then we're going to be able to get that list of terms returned right there. So let's go ahead and start off by creating a new file, once again in our lib folder, and this is going to be called define term response. And in order to use terms inside of this file, remember that we're going to have to import our term.dart file. So just before we even get to that, I just wanted to get that out the way. Let's go ahead and create a class that's going to have a list property, which is going to be a list of terms. All right, so simple enough. We have our class called define term response. We have our initializer right here, which can be initialized with an array or a list of term objects, and that's just going to be stored in the list property. So we have this object, this define term response object, that's kind of set up for us to start receiving responses. But in Dart, you have to actually manually decode your responses. So what we're going to do is in our term object, we need to create a new function that's going to allow us to initialize a term from JSON. So let's go ahead and start implementing that right now. All right, so before I continue, I just wanted to go over this syntax real quick. So what we have here is we're creating a function called from JSON. Now it's a little bit weird because of the syntax. We're doing term dot from JSON even though it doesn't have this function. This is actually declaring this function called from JSON. So it's going to be a function on a term, and what it's doing is it's expecting a map. So you could think of this like a dictionary where where it's expecting a string for the key and any for the object or for the value. So string and any is what this would be in Swift. And then the parameter that's being passed in, we're just going to call it JSON. So this JSON object is essentially a dictionary of string and any. So let's go ahead and finish the rest of the implementation. And what we're going to do is we're going to parse out whatever JSON is given to this function. So whatever's passed into this, we're going to parse out this JSON based off of whatever keys we're expecting to receive, which are these values right here in our term object. So we're expecting to receive term, we're expecting to receive thumbs up, word, and thumbs down. Now, what you're going to see is that we don't have thumbs up and thumbs down in our term object. So we're going to actually be taking those keys and mapping them to our likes and dislikes. So let's go ahead and take a look at what that looks like. So as you can see, we're able to use the JSON parameter that was passed in this syntax without any curly braces. And we're just saying whatever value is in the JSON under word, we're going to map that to word. For definition, definition. For thumbs up, we're going to map that to likes. And then for thumbs down, we're going to map that to dislikes. So now we can actually create a term object with this method. And that's what we're going to actually be doing over here in our define term response.dart file. So go ahead and save this file and let's switch back over here. And now we're going to do essentially the same thing for this define term response, but since we actually need to do some work in order to map these terms into a list of terms, since we're receiving the actual JSON here in our define term response, we're going to have to do slightly different syntax than what we did on term, and you're going to see that right now. All right, so pretty much the same format in regards to from JSON right here, and once again, this can be called whatever you want, but this is the standard Dart convention that is recommended. But as you can see, we're once again creating this function called from JSON that's receiving a map of string and any, and we're receiving this JSON as a parameter. Now, we're using this keyword as a factory because we're still creating a defined term response object, but what we want to do is we actually want to initialize it this way. So inside of this factory, you could think of factory kind of like convenience init in the sense that you're able to still create this object, but at the end of the day, you still need to call one of the predefined initializing methods, which is this one. So essentially what we have to do is we have to go through, create the logic to initialize this list with a list of terms, and then we have to actually pass that into define term response to initialize that object. So that's kind of the difference between doing it with factory and doing it with term. Here, this is just like a regular initializer. Here, it's kind of like the convenience init where you actually have to call a real initializer. So those are the differences. So the very first thing that we need to do is we need to make sure that our response, the JSON that we're getting, actually has a value called list in it. So let's do that. All right, so here we go. We have our JSON and we're checking to see if this JSON has a property called list, and we're also making sure that it is a list. So it is an array of some type of object. It doesn't matter what type of object as long as it's an array of an object. If this is true, then we're going to go ahead and start the decode process. But if this is false, then what we're going to do is we're going to trap and kill the app, and we're just going to say no list in response because we handling errors today, like I said. So let's go ahead and access this this JSON as a list. All right, so what's going on here is we're going to go through two forms of cast. So we're going to first cast it as a list, and it doesn't matter what kind of list, but we just need it to be a list object. Once we know that it's a list, then we can cast that list into a list of map objects. And now we have this objects list. So once we have a list of objects in this format where they're maps, and this type is the same as our from JSON from our term, as you can see here, same exact type, we can pass that object directly into our from JSON. So that's what we're doing with map. So this map is pretty much the same as the map in Swift, where you're iterating over each element in this array or in this list. So we're passing in each object or element, which is this E right here, this element is being passed in to this function right here, term.fromJSON. And since each object is of this type, we're passing instance of that type in as E right here, and we get a list of terms, and you'll see that it's an iterable term. So now what we need to do is we need to initialize an instance of this term response and return it. So let's do that now. So as you can see here, if we pass our terms list into our define terms list response initializer, which is right here, we're not getting any errors. But the problem here is that we actually are passing one type in when we're supposed to be passing in a list. So if you hover over terms list, you're actually going to see that this is of type iterable. So even though lists and arrays are iterable, it doesn't necessarily mean that you can pass an iterable into a function that's expecting an array or a list. So just think of it this way. All lists and arrays are iterable, but not all iterables are lists or arrays. So what we need to do is we need to actually we need to pass in term list, but we need to do dot to list. So this is actually a very common pattern in Dart. So if you may have something that's very similar to the type that you're working with, but it's not exactly the type that you are looking for or are planning on working with, and usually there's this dot to and then whatever type is more common to work with. So in this case, we need to change this to a list, and as you can see right here, it's going to give us a list of terms. So that's exactly what we need. All right, so that's all we need to do for our define term response. Now, once that's all saved, let's go back over to our networking service and let's get this all wrapped up. So I'm going to start off by removing these comments right here since everything's already been implemented in code, as we can see. And we had our response that we're getting back. If we get the response and the status code is 200, then that means that we're good to go. And now what we need to do is we need to create an instance of our defined terms response. So let's go ahead and do that. All right, so here we go. We have this defined terms response right here, right? And we're setting it equal to defined term response from JSON. So this is the function that we just created, and the JSON decode function, which is going to essentially take the response.body, because the response.body that you get is actually a string. So everything that comes back in the response is actually returned as a string, and then this JSON decode actually takes that string and it turns it into a properly formatted JSON object and can detect all the different types and things like that. So we're actually going to take that decoded string, turn it into actual JSON, and pass that JSON into our from JSON function. So that's what's going on right here. We could also do this on a second line if it makes it a little bit clearer. So we can have decoded body. All right, so as you can see here, we have decoded body, and this isn't something that we would normally have to worry about during native iOS development. When we get back our object, we usually use something like JSON decoder, and that will take in an object and can map all these things for us. But we have to do the mapping ourselves, and this JSON decode right here is just taking the string of the response and turning it into a map. So as you can see, we have this dynamic object here. So now that we have our defined terms response, that means that we also have our list. So now we can actually return our list. And that's all we have to do. So notice that this type is of type list, a list of terms, right? And we don't have to do anything special, even though that we're expecting this future right here. We don't need to wrap it in anything special. The reason why this conforms or is the same type of future list terms is because we had to do this await. So when we have this await, we're going to do some asynchronous code, right? And that's why we had to specify the async. But everything after this point, anything that we return is technically in the future. So that means that since we're returning this list of terms, it's going to be a future list of terms. So that's why we're actually returning a future list of terms instead of just a list of terms right here in the as the return type. If you were to try to just return a list term, this would not work. So just keep that in mind. But our networking service is all done. We're not going to do it any more advanced than that. So let's go ahead and create an instance of our networking service. And let's go ahead and put it in our main.dart file. So up here towards the top, I'm going to go ahead and create an instance of my networking service. So now I have a private instance of my networking service, and I can go to where I'm doing my search for term, and we can actually call define term. So let's go ahead and do that. And I'm going to make sure that I do that outside of the set state because we don't want to do any asynchronous operations inside of the set state function. So let's go ahead and get those search terms or the response terms. All right, so as you can see here, we have our terms, which is awaiting a networking call from our networking service called define term. So we're passing in the term that they essentially press search on. Then we're passing whatever they sent in, running it against the API. We're going to get back a list of terms. And now what we need to do is we need to hang on to this list of terms. So let's go ahead and create a new property where we can hang on to each of these terms. All right, so as you can see, we have this list of terms right here. And what we want to do is we want to update our state, and we want to set this response terms to this terms up here. So let's go ahead and update that. And we actually want this to be an empty array. So, and this needs to be variable. So let's go ahead and make sure that this is an empty array of terms like so. All right, so we have our empty array of terms like right there. And now instead of showing just the dummy data, we can go down to our terms right here where we're creating our terms page. And we could just pass in this dot terms like so. And if we restart the app, we should be able to see our app update with real data. So let's see if it works as we expected. So I'm going to go ahead and type in hello. So I'm going to go ahead and type in hello world. And let's go ahead and search for that. And as you can see, boom, we're getting real data. Hey, yay. And if we go ahead and click on it, we're able to go in, we're able to see the definition, we're able to also see the likes and the dislikes. So really cool stuff. We have all of our stuff working, all the networking's working, we're able to go between screens, we were able to set up our navigation, all that great stuff. The only thing that's kind of bugging me is the fact that we have these square braces around specific words. So what I want to do is I'm going to actually go through each string. I'm going to parse out each of these open and close square braces, and we're going to turn them into bold tags. And then the reason we're going to turn them into bold tags is because we can get another package and we can essentially render this string as an HTML string, which means that anything that's in bold tags will actually be bold. So let's go ahead and go over to our pubspec.yaml. And what we need to do in here is add in another package called Flutter HTML. Now let's go ahead and find Flutter HTML on pub.dev. And we'll just search for it, Flutter HTML, like that, right here. And if you want to see some of the pictures, you can go to the repo itself, and you can kind of see that what it's doing is it's taking in HTML string, so any formatted HTML, and it's just marking up the UI right there in the app, which is really cool. So let's go ahead and go back, and we could take a look at the installation instructions, and we're just going to grab this right here, Flutter HTML 1.0.2, and we'll just drop that in. Then we'll hit save. It's going to install that package for us, which should be relatively quick. And well, it's still going, but there it goes, and all done. Now let's go back over to our term object, and what we want to do is we want to create a new computed property which will allow us to take our definition and replace each of those square braces with the correct tag. So let's go ahead and do that now. All right, so as you can see, I created this new computed property, and this is how we do computed properties. We would specify the type, we say get, and then the name of that property. And we're just going to simply return the definition, but we want the definition to replace all occurrences of the open curly brace with this B tag, and replace all occurrences of the closed curly brace, of the square brace with this closed B tag, closed bold tag. So now what we can do is we can save this, and we can go back over to our terms page. We can install HTML or Flutter HTML. So we have our Flutter HTML package imported, and we're going to scroll down to our list tile, and for the title, for the subtitle, we're actually showing the definition. What we want to do is show the HTML definition, but not only that, we want to show a HTML instance. So this HTML instance kind of acts similar to a text in a way, and all we have to do is specify that this is the data that we're passing into the HTML object. So now the HTML object is being rendered, or is going to be rendering our HTML definition, and let's take a look at what that looks like. So we go back, and as you can see, it's starting to bold all those different tags. So that's really cool. We still need to go in and change the details page because we're still showing those square braces, but that's a pretty simple fix. So we head over to our term details page. We're going to go to the definition, change this to HTML definition. Then we want to also create an HTML object, make sure that we import that, and then we're going to specify that we're going to be passing the term.html definition in for the data parameter. So let's go ahead and save that, take a look at it, and voila, we have our we have no more ugly square braces. Everything's just simply bold, and you can obviously do whatever you want with with those words. You could make them hyperlinks to link to other words. That's perfectly fine. But I'm just going to leave it right there because this video is long enough. So that's going to do it for today. I hope that you really enjoyed the video. I hope that I didn't go too fast or too slow. I really wanted to explain everything, and I hope that I was able to explain it in a way that's very relevant for a Swift developer to kind of catch on and get started with Flutter. I know that it's like dramatically different than doing native Swift iOS development, but it is a very fun way to actually be able to build stuff out, do everything completely declarative, and also be able to develop for both platforms. Now, before I let you go, I think the very last thing that I want to do is be able to run this app on a real device. So I have my real device set up. Let me just get it displayed on the screen. All right, I have my device plugged in, and now all I'm going to do is I'm going to hit F5 and have it run on my real device, which you can see right here. I have my, this means Samsung, and this is a Galaxy A11. That's the type of Android device. It's going to take a little while, then it's going to build, but we want to make sure that it actually works on both iOS, which we saw in the simulator, and that it also works on Android. All right, and there it is. Bam, right there on an Android device. Look at that. That's a real device right there. Bam, it's right there. So let me go ahead and enter this in. This is, let's go ahead and type in programmer and define what a programmer is. All right, and search for it. And we get our results back. And as you can see, it looks just like the iOS version. Bam, look at that. Isn't that so cool? And let's see, let's just click on one of them, make sure that we can get it. And there you go. So I like this. I like this definition, but that's what we are. We're programmers. So there you have it. That's all I wanted to cover for today. We got pretty much a lot of the basics out of the way for Flutter, and you should be able to reference this project a lot in the future. And once again, projects is the link to all the code is in the description below, but I really hope that you went through and you actually followed along and you typed out all this stuff yourself so that you can start internalizing a lot of these concepts and get more comfortable with writing code in Flutter. Because worst case scenario, you don't like the way that maybe you don't want to do this for creating cross-platform apps, but you could potentially learn this and just only use this for your Android app development. So that's like one possibility. Like maybe for whatever reason you want to do native Swift on iOS, but for whatever reason you just hate working with Java or Kotlin or something like that, and you still need to make an Android app, well, you could do it in Flutter. So that's just, something to think about. And I really enjoy Flutter. I hope you do too. I hope you learned a lot. And if you want to see more videos on Flutter, I'm going to be covering it a lot more in the future. So make sure you subscribe if you want to, see more on that. If you made it this far, I'm assuming that you definitely do. So thank you for your time. I really appreciate it. Now go out there and keep coding passionately.